You've certainly heard of a centimeter as well as meter. Centi would be the prefix of that, the same way that 1 cent is 1 penny. It's 1/100th of that value. So, if you're in my class, I've given you worksheets to give you lists of many of those prefixes. If not, you can look them up. There's a billion of them online. So if you were to think about a centimeter, 1 centimeter is 1/100th of a meter, which is the same thing as 10 to the negative 2. You could either account for this in having the meter be smaller or the centimeter be larger. No matter which conversion factor you're using or which of these two values that you're using, they're the same. That means the same thing. So don't worry about whether you have one or the other, but I do encourage you to be consistent and make sure that you're using the same type of system and you don't suddenly read down another line by mistake instead of reading across that line, okay? Now, let's say, I'm going to use the 100 centimeters equals 1 meter, okay? Let's say that you have this equation, okay? Stick with me here for just a second. If I say on top, 100 centimeters equals 1 meter, I could mathematically manipulate this. Divide each side by 1 meter, and that equals 1 over here. So 100 centimeters over 1 meter is equal to 1. Or I can start with the same equation and do the opposite. I can divide each side by 100 centimeters. Guess what? That still equals 1. Well, here's the thing. Remember in math, you can multiply anything by 1 and it doesn't change it, right? Well, when we're trying to figure out how many centimeters you have in your measurement and you measured it in meters, or somebody else did, or whatever the case may be, you're trying to convert from one type of measurement to another. If you multiply something by this, you're really multiplying it by 1 as far as the value is concerned. It's not changing the value, it can just help you change the units. I repeat that. It doesn't change the value, it changes the units that you've reported something in, okay? Now there's times that you're going to use it for changing units, but that's not these. Or changing values, but not these, okay? So let me show you how to write this. These are both referred to, by the way, as conversion factors. So let's say, for example, we have a question. And it says, how many centimeters are in 0.05 meters? Well, I'm going to start with saying I have 0.05 meters. And because I have this unit, I don't want to have that unit anymore. I want to have it in centimeters. I'm going to multiply this by the one that of these two options by the one that has the meters on the bottom. The reason why is because that means it will cancel out. Okay? So I have to take this entire thing, I can't pick and choose, I have to take this entire thing and put that there. By doing that, I cross this out, I cross this out, I've got my unit now as centimeters, and you're in 5 centimeters. Now guys, I'm going to tell you something real big secret here, okay? Ready for this? If you use your units, it lets you cheat. It lets you see what you have and where you need to go. But if you don't write your units, you will get confused with something. Eventually, it will catch up to you. So it's really, really, really beneficial for you to write out those units. Even if it looks like chicken scratch, as long as you can tell what the chicken scratch is, that's fine. Just make sure you write that out. It's really important to do that, okay? These are simple problems. It's going to get much more complicated. So here we have, how many meters are in 1200 centimeters? So we're going to convert this 1200 centimeters to meters. We've got 1200 centimeters. In this case, I'm going to use this guy, the opposite. And the reason why is because I need my centimeters to cancel out. I need to get it in meters. And so that's why I use that, and bam. So when you're trying to figure out prefixes and how to go from one to the next, look at how they relate to each other and realize you can divide it by either side to get something like this. Eventually you can do this in your head, but certainly for the first few you definitely need to write this out and make sure that you know where you're coming from, where you're going to, okay? Now, what I just showed you is the beginning of what we refer to commonly as dimensional analysis in chemistry. And this is one of those topics that people start to cringe over usually. I don't think it's like that because I think it's fun. You're just changing one view of reality for another a lot of times, okay? You can convert a lot more than prefixes. You can get much more complex if you want to, but this is meant to be a general guide. It is so much easier if you start with what you have and figure out where you're going. You find the stuff that goes in between or anything that will help you relate from where you're going, where you're coming from and where you're going to. And then you multiply the conversion factors so that whatever is on the top of one number is on the bottom of the next one. They just keep canceling out, okay? You continue until you have your unknown, and then you calculate by multiplying everything on the top and dividing everything on the bottom. So we forget that sometimes. So let's say we have a 12-ounce steak. Okay. You want to know how many kilograms of steak you have. You may go ahead and look these things up, or you might be given. 1 pound is 16 ounces. 1 kilogram is 2.2 pounds. Okay, so I've got all this information. Where do I start? Remember, let's start with what we're given, okay? Let's start with this number here. That's the easiest thing to do. So whatever you're given as what your starting point is, you want to put usually right there, okay? Now, I see that 1 pound is 16 ounces. Now remember, that means that I could say each side divided by 16 and get this from there, okay? So I got this guy into this format, and that's where he came from. By doing that, I can scratch out this ounce and that ounce, right? Because they're going to cancel each other out. Wait, where are we going again? We're going to kilograms. We're not going to pounds. So we need to keep going. You do not have to write out the answer and then write something else out. Just keep going. You're going to have these like huge long lines. That's okay. Your calculator can handle it. If not, you need a new calculator. Don't worry about that. I also have a way to relate kilograms and pounds. So I have a pound up here. I want my pound down there. So I can divide each side here by pound, and that means that 1 kilogram divided by 1 pound is what that next one would be. Actually 2 pounds, sorry, excuse me. 2.2 pounds. And those pounds cancel out now. So to get the actual answer, I'm going to take 6 times 1 times 1, which is just 6, and divide it by 16 and divide it by 2.2. And that gives me my answer. 0.17 kilograms. And if we do sig figs, 0.2, because we only have one sig fig right here. Guys, you have to do a lot of these. Nobody ever understands it by staring at it. You have to take paper out, you've got to put a pen or a pencil to it, and figure out how to do this. No matter how many problems I show you, it's not going to help until you start to try to do these yourself. Can't stress that enough. You can't sleep on your book. You have to actually take out pencil and paper and try to do these, okay? There are a plethora of resources. Go just Google it and I promise you'll find stuff. There's all kinds of stuff out there. If you need to know if it's a good source or not, let me know. I'm happy to look at that. I've got plenty of problems. I just don't want to overwhelm you with it either. Okay, another little side note, we sort of dealt with this a little bit before, at least in class. Density is defined as mass over volume. It's a definition of whatever substance you're dealing with. So a piece of wood is going to have a different density than a hunk of steel, right? And density mathematically is defined as mass over volume. The units here mean that you have units both above and below that mark. Now I'm assuming that between right now and what we did on the previous page, you've done some examples. Because you don't want to jump straight into this example until you've done some more examples doing the easier things. But let's go on. If an object is 0.96 grams per liter, so that's a density, how many grams it is per volume, what's the density in grams per milliliters? This is telling you that you need to figure out a conversion between liters to milliliters. What makes that a little bit more difficult is the fact that you have not just one unit here to keep track of, but that you have two. So hopefully you know that 1 liter is 1,000 milliliters, or you can look that up somewhere. So I'm still going to start with what I'm given as the number and realize where I'm trying to go. Grams is not changing. Milliliters is what's, or liters to milliliters is what's changing. So if I do this, instead I'm going to have to put the liters on top. And the reason why I do that is because that's the only way for it to cancel. If I were to put liters on the bottom, and this is what I mean by your units can help you cheat, that means that you get unit or liters squared on the bottom. That don't make no sense. So something would be wrong with that. That's the reason why we have to cancel these out and instead get it into milliliters. So see what I mean by that can help you cheat? Because if these cancel out, grams is on top, milliliters on bottom, and guess what? That's exactly what it tells you that you're supposed to get. That's a way to sort of tell. Okay. So once you take 0.96 divided by 1,000, this would be your answer. Or in scientific notation, it would be like this. In other words, it's very light. There's also a measure known as specific gravity, and this is a value that compares the density of a substance to that of water. So the specific gravity is the density of an item or substance, whatever that may be, over the density of water. And this is kind of cool because if you have units up here and they're the same thing as down here, all the units cancel out. And so it has no real unit in this. But if something's heavier than water, it's going to mean that the specific gravity is greater than 1. If it's lighter than water, then the specific gravity will be less than 1. This is used a lot of times when looking at urine samples because you can sort of tell how many other things are inside your urine and tell how dehydrated or hydrated you are in that way. Okay, thank you very much.